Okay, so if f is an odd one-to-one function, then f inverse is also an odd one-to-one function. So what is odd function? We have definition of odd function is f negative x equals to negative fx. So we also have the definition for even function. So for even function, we have f negative x equals to fx. So we just use this to test about whether the function is positive or negative. In the previous page, we have questions about odd and even functions. If you don't know what's odd even function and you don't know how to recognize odd even functions, you can go back and find those pages. And I have solutions on the portal in the Google Classroom as well. So that's just a definition. If you know a function is a one-to-one function and it's an odd function, then the inverse must be a one-to-one odd function as well. So example will be fx equals to x cubed. That is a one-to-one function. And also we can test, okay, f negative x equals to negative x to the power of 3, and f negative x will equals to negative x to the power of 3, f negative x will equivalent to negative fx. Because x to the power of 3 is fx, we have negative fx. We know this is an odd function, and we know it's one-to-one. I tell you that cubic function, if I'm going to find the inverse of cubic, that will be a cube root function. So the f inverse x must be cube root x. Okay, if you can follow the procedure and find inverse function, that must be cube root function. Okay, if that's a cube root function, think about what cube function looks like. Okay, that's a cube root function. That is a one-to-one function as well, and that is an even function as well. Okay, it is odd function. It is odd function and it is also a one-to-one odd function. Okay, so that's what this line is talking about. If you have a one-to-one odd function, your inverse must be a one-to-one odd function as well. Okay, so that's just a little definition here. And let's go to think about how to sketch all the following power functions. Let's think about the first one. Okay, we have fx equals to x plus 1, x to the power of negative 5 over 6. Okay, let's think about things one by one. If we have a gx equals to x to the power of negative 4 over 5, to the power of negative 5 over 6, and compared to fx and gx, the graph of fx is just move gx to the left by 1 unit, right? Plus 1 is moving to the left by 1 unit. So if you can draw gx and move that by 1 unit to the left, you'll result in the function of fx. So first thing we need to think about is how we can sketch f to the power of negative 5 on 6. So step by step, x to the power of 5 on 6. What's this graph looks like? This is, you must have graph in the first quadrant, right? You must have graph in the first quadrant. And think about if x is negative value. This equals to x to the power of 5 to root 6. Okay, if x is positive, you must have a positive value always in the first quadrant. And think about if that's negative. Negative x value to the power of 5 is still a negative value. But now you want to take an even root. You cannot take even root. So you don't have graph for x equals to negative values. Okay, so this is odd on even case. If it's odd on even case, we can check. Okay, odd on even only in the first quadrant. Okay, not in the other quadrant. So we only have graph in the first quadrant. And this is a graph 5 on 6 is smaller than 1 and in between 0 and 1. So your graph will roughly look like this. Okay, this is a graph like the shape of your graph. And we want to look for the reciprocal function because we have a negative in front. What I want to sketch is 1 over 5 on 6. If I'm going to sketch 1 over 5 on 6, so that is x to the power of 5 on 6. Find the reciprocal. The reciprocal will be, that point is 0, so I have vertical asymptotes here, x equals to 0. And because x to the positive, the graph to really high, so we will have horizontal asymptotes as well because it's finally approaching to 0. So this graph will look like this. Okay, this shape will look like this for this graph. Okay, and now don't forget, you need to move this graph together by 1 unit to the left because we have the plus 1 in the bracket. X plus 1 means moving the graph to the left by 1 unit. So your asymptotes will be shifted by 1 unit to the left. So now combine all this information. We will have -1. And we will have, okay, again, if y equals to 0, that's on the x-axis, you still need to sketch it. Okay, still need to sketch it. Use a different color or really obvious colors to sketch asymptotes. And you know when x equals to 0, 0 plus 1 is 1. 1 to any power will be 1. So when x equals to 0, that point must be 1. 0, 1. And the shape look like this. Okay, that is the graph. Okay, that is the graph. So we have 0 and 1 here. We better label another point. We better label another point. We can label 1. Not necessary to be any number you can calculate. Maybe just label 1. X equals to 1. 1 plus 1 is 2. So it's 2 to the -5 on 6. You can leave your answer like that. You just need to label another point on the graph. You need to label 2 points on the graph. Okay, you need 2 points on the graph. Because we don't have x-intercept, we only have 1 y-intercept. We don't have any other key features on this graph, so we just generally label any point. Okay, just make sure, okay, this point is on this graph. Generally label a point. Okay, so this graph will be the final graph of this fx function. Okay, of this fx function. So 2 to the power of -5 on 6. Okay, let's have a look at next one. We don't have the c here. Okay, so fx equals to x to the power of -3 and gx equals to x to the power of -1. So that's 1 over x to the power of 3 and that's 1 over x to the power of 1. Let's sketch x to 1 over x first because we know how to sketch 1 over x for sure. So y x, so 1 over x, that's a hyperbola function. I have x equals to 0 and y equals to 0. Have 1 over x. I'll use the blue color to sketch it. Okay, another thing I want to emphasize is see the end of the graph must be parallel to your asymptotes because it means it's approaching to, not far away, not close to, so it must be parallel in the end. Same as the vertical one, needs to be parallel. Okay, so that's my 1 over x. So that is my gx function. That is my gx function. At which point these two graphs will meet? When the two graphs will have intersections. Intersections? If asked you what's the intersection between the two graphs, how you can solve for that? For power functions, 1 or -1 is always the key thing, right? 1 to any power and -1 to any power, you still have 1 or -1. And if I want to solve this, so I'll times x to the power 3 on both sides. You solve out x equals to plus minus 1, right? You solve out x equals to plus minus 1. So let's say we have 1 and 1 here, and minus 1 here. So now the next thing we need to think about is which graph is higher than which graph is lower than which graph. Okay, let's think about one point. Let's say x equals to 2. Let's say x equals to 2. When x equals to 2, fx equals to 1 over 2 to the power of 3, and gx will equals to 1 to the power of 2. Which one is higher? Which graph is higher? G, right? G is higher. So gx should be greater than fx at x equals to 2. And they intersect once at point 1, 1. Therefore, the graph must look like this. Gx needs to be higher at 2, so must be lower before 1. Okay, the intersects there. If something intersects, must be before that point, one graph is higher than the other one, and past 1, the other graph needs to be higher than the original one. Otherwise, how they can intersect? Think about two things can intersect. Must be one higher, one lower, and they swap that after the point of intersections. So at x equals to 2, which is greater than 1, when x greater than 1, your gx needs to be higher than fx, which means before x equals to 1, your gx needs to be lower than fx. So same thing here. Okay, the blue one is your gx function. The blue one is your gx function. And your fx function needs to be lower than that. Like this. Okay, that is your fx function. So you have 0.11 and -1, -1. Because say when x equals to -2, f -2 equals to 1 over -2 to the power of 3, which is -8, and g -2 equals to -1/2. Okay, -1/2 is more negative. Okay, -1/2 is more negative. So to the left of point x equals to -1, gx function needs to be lower than the fx function. So therefore the graph will look like this. Okay, so the important thing to think about power function will be which graph is higher than which graph and which point they intersect. When you sketch them, if there are two graphs on the same set of x-axis, you need to think about, okay, which point is higher, which point is lower. Okay. So 1 is always the key point. Okay, 1 is always the key point. Okay, next one. Next one, fx equals to x to the power of 1 over 5 and gx equals to x to the power of 1 over 4. So, okay, fx equals x to the power of 1 over 5 and y equals x to the power of 1 over 4. Let's think about this should be in the different quadrant because it's...
There's no one that is seeing is to office to the late class.
Just coming. Okay, so we have odd on odd and odd on even. They must be in different quadrants. Okay, they must be in different quadrants. So if it's odd on odd, okay, odd on odd is in the first and third because they are all odd functions. If you have positive, you come out with positive. If you have negative, you come out with negative. But odd on even will only have one quadrant. 1 on 4 is same as 1 on 2. 1 on 2 is square root x. Think about where is square root x. So a quarter root of x must be in the first quadrant as well. So we have 1 and 3 and only 1 in the second one. So let's sketch. Okay, x to the power of 1 on 4. It just looks like this. Okay, that's my gx function. It can be any height, like it's not necessary to be scaled, but you know that gx function will roughly be there. And now we want to think about fx function. Okay, if this is my fx function, I will think about they must intersect at the point 1, 1. Okay, I hope you know that now. 1 to the power of anything will be 1, so they must intersect at the point 1, 1. If they intersect at the point 1, 1, okay, after 1, let's say x to the power of 2. So 2 and 2, which one will be larger? Gx will be larger, right? Gx will be larger, so fx will be lower. Fx will be lower. So if fx is lower, fx needs to be higher before 1 then. So the graph will look like this. It's not very up. Let's draw that again. Okay, they're quite close to each other, but you know that they intersect at 0, 0, they also intersect at 1, 1, which means they like a cross shape. So fx needs to be lower than gx after 1, which means it must be greater than fgx before 1. And now we have another half of this graph. Like you need to show it's quite symmetrical, and also have the point -1 and -1 here. Okay, and that's my graph. And look at, I'll make that larger. Look at what the green graph and the blue graph goes. Okay, the blue is above green first, and then the green is above the blue one later. Okay. Okay, the last one. The last one is fx equals to x to the power of 2 on 3 plus 1. This is x to the power of 2 on 3 and over 1. If plus 1 is go up by 1 unit. So we just need to think about what is x to the power of 2 on 3. So if we think about x to the power of 2 on 3 is x to the power of 2 and then take the cube root. So it must be in the first quadrant. If x is negative, x squared will be positive as well. Positive number, take a cube root, is still positive number. So when x is negative, y is positive. So in the first and second quadrant. And also this is a graph smaller than, in between 0 and 1. Okay, so it's like this shape. And you want to move this graph 1 unit up. 1 unit up. So we will have think about the sharp point here. A little bit revision from last year. If you want to derive this function at the point x equals to 0, there's no gradient there because the tangent is a vertical tangent. X to the power of n. X to the power of n. If n is smaller than 1, say fx equals to n. If n is smaller than 1, f dash 0 is undefined. Because that's a vertical tangent, the gradient is undefined. If fx equals to x to the power of n, n is smaller than 1, then f dash 0 is undefined. At that point 0 is undefined. And we can see this graph. We can see this graph. We have 0 and 1 at this point. And we have my graph looks like this. Ugly. Okay, the shape looks like this. You try to draw a symmetrical. Okay, that's more symmetrical now. And I will label another 2 point, -1 and 2 and 1 and 2. Okay. Any questions? I'll show like each kind of graph. One example, we have draw the reciprocal. We have draw in different quadrant ones. Okay, so that's for power function. So for power functions, think about two things. The first thing, whether it's in which quadrant it should be, number 1 or 1 and 2 or 1 and 3. There are 3 cases. It's never in the fourth quadrant. And the second thing think about is in between 0 and 1 or greater than 1. When we see the reciprocal functions, we'll draw the denominator first, and we think about when 1 divided by those values, what the graph looks like. It's more like a truncus or hyperbola. Okay, it's like a truncus or hyperbola. Okay, let's see page 33 about some application questions. Okay, for this application question, a rectangular piece of cardboard has dimension 18 times 24. 4 squares, each x times x, are cut from the corners, and open box is formed by folding up the flaps. Find the function v, which gives the volume of the box in terms of x, and state the domain of this function. So this is a very, very common question. We see a lot of mock exam papers will give you similar type. So if we have a rectangular, that's not really a rectangular, let's assume it's a rectangular. We cut x from each side. If we cut a larger x, that will have a higher height. If we cut a small x, that will be a very low box. But okay, if I cut x and I fold the piece, so this will be my base. Can you think about that? All this square just gone. We don't have those squares anymore. And what we left is for the 4 side, like number 1, number 2, number 3, and number 4, we fold them up, and we have a height of x, and what we has been left as this blue rectangular is the base of this box. Okay, the more you cut, the less the base you have. Okay, more x you cut, the less of your base left. So what is my base? So this is 24 times 18. So the base will be 24 minus 2x and 18 minus 2x. Okay, for 24 minus 2x and 18 minus 2x. So the volume will equal to base times height. So the base will be 24 minus 2x times 18 minus 2x and times x of the height. Length times width times height. Okay, length times width times the height. So that's the volume of this box. You don't need to really open the bracket. If you want to open the bracket, you can use your cast to open the bracket, but I'm not going to do that. What I worry about is the domain of this function. So what's the domain of the function? What are the restrictions you can see from this graph? What are the restrictions? Can my x be 100? Can x be 100? Can x be smaller than 0? No. Okay, so how we can find out what is the largest value my x can take? X smaller than which value? 12? 9. Okay, so what we need to think about is my length, width, and height all needs to be greater than 0. Right? My length, width, and height all needs to be greater than 0. Okay, so if you only talk about my volume to be 0, I can have a negative length, I can have a negative width, and I have a positive height, and still a positive volume. We cannot think about the volume. We need to think about the 3 components separately. Length, width, and height, all measurements, they all needs to be greater than 0. So we need to think about 24 minus 2x needs to be greater than 0. 18 minus 2x needs to be greater than 0, and x needs to be greater than 0. And I want to solve them simultaneously. Have x smaller than 12, x smaller than 9, and x greater than 0 after you solve them. Okay, so we have 0, 9, and 12. I have x smaller than 12, which is here. X smaller than 9, which is here. And x greater or equals to 0, which is here. Which part is the common part? Okay, from 0 to 9. Okay, from here to here, you have 3 different color lines, which means all these set of values will contain 0 to 9 as a solution. So your x will belong to 0 to 9. Okay, will belong to 0 to 9. Okay. That's not very hard question. Let's think about example 2. Let's think about example 2. Example 2. A rectangle is inscribed in an equilateral triangle, and the dimension as shown below. We have 2x, we have y, and we have h. H is the height of the triangle, and y is the height of the rectangle. Find the area of the rectangle for a function of ax and state the domain. Okay. Now we have the equilateral triangle, 15, 15, and 15. Okay, so what is the ax should be equals to? Ax should be 2x times y, right? 2x times y must be the area of this rectangle for sure. But like y is not in terms of x yet. We need to find y in terms of x. We can see this is a triangle question. If it's a triangle question, okay, when you see the common thing we use to solve this type of question is similar triangles. We use similar triangle a lot. Okay, so if you have cylinders, you have cones that all use about similar triangles. Okay, we use similar triangle a lot. We're not using congruent triangles a lot, but we use similar triangles a lot. If we can think about the similar triangle, okay, if we can think about the similar triangle, how we can make y and x get a connection. So here is the y, and we have an h value here. Okay, and this part is x. This part is x because we have 2x as the whole length. So half of that will be x. And we know this part. We know this part will be what? Will be 15 on 2 minus x. Do you agree with that? 15 on 2 minus x, because half of the base minus the length of this rectangle. Okay, half of the length of rectangle. So from the point C to D, that's half of the base. That's half of the base, which is 15 on 2. And you minus the x, which has been what has been left. So it's 15 on 2 minus x. Okay, so what I can write here, triangle, let's give this point a value e. Let's say that's e. So that's x, that's e. what I can write is y over h will equals to 15 on 2 minus x over 15 on 2. Right? 15 on 2 minus x over 15 on 2 equals to y over h. So if you can see that that's F point, so triangle CEF, is similar to triangle CDA. Okay, the small triangle is similar to the big triangle there. So y over h will equal to 15 on 2 minus x over CD. Okay, CE over CD equals to EF over AD. Okay, if you can see the ratio. So now y will equals to what? Y will equals to, okay, 15 on 2 over 15 on 2 is 1. 1 minus x over 15 on 2 times h. Times h. Okay, y in terms of x now, but it's also in terms of h. What is h? What is h? H is the height of this triangle. Okay, h is the height of this triangle. We have an equilateral triangle and we know the side length. Can we find the height of this equilateral triangle? Yeah, we can find that. How we can find the height of an equilateral triangle? Do not tell me you use Pasag. Okay, it's 2 waste of time. I hate Pasag. When you learn trigonometry, you learn circular functions. Why we use Pasag? Okay, we have no choice. We need Pasag. Okay, that will be the case. If you know all the ratios already, we are not using Pasag. If you can see, okay, that's the h. That is 60 degrees. Okay, equilateral triangle, 60 degrees. 60 degrees will tell you something already. And that is 15. So sine 60 degree will equals to h over 15. H will equals to 15 sine 60 degrees. What is sine 60? What is sine 60? Still can't remember exact values. What is sine 60? A half or root 3 on 2? A half or root 3 on 2? Choose one. Okay, cosine 60, cosine 60 is a half. So sine 60 will be root 3 on 2. Okay, so 15 times root 3 on 2 will be the h value. Okay, it's easier than Pasag. Because Pasag, what you need to do is 15 squared minus 15 on 2 squared and square root the whole thing. Okay, that is what you will do for Pasag. Without CAS, I don't think you can calculate that really quickly. But like if you can use trigonometries, you use sine, cosine values, that can be really easy. But the case is you can remember your exact values. Okay, if you can remember your exact values, that can be a really quick method. So h equals to 15 on root 3 over 2. Okay, that's my h value. Okay, that's my h value. Let's sub h value back to the y. So y equals to what? Y equals to 1 minus x over 15 on 2 times h. So times this. So y will equals to 1 times that, open the bracket, we have that. And we have minus 15 on 2 times 15 on 2 times root 3. They can be cancelled as 1. So y equals to 15 root 3 on 2 minus root 3x. It's just really a lot of calculations. Okay, it's just really a lot of calculations. If you can simplify that correctly, you will have this answer. Okay, so that is my y value. That is my y value. So I'll put the y value back here. So ax equals to 2x times y. So y is 15 root 3 on 2 minus root 3x. If I can open the bracket, so the 2 and 2 just cancelled, and we have 15 root 3x minus 2 root 3x squared. Okay, we have that. If you do all the calculations right, you will have this answer. Okay, you will have this answer. So think about what we have done for this question. Okay, first of all, we represent how we can figure out the area of this rectangle. Okay, this rectangle equals to length times width, which is 2x times y. I need to find y in terms of x, so I need to connect y and x together to find an equation to connect them and make y to be the subject. And now we can find a similar triangle which contains y and x. So I use this similar triangle y over h equals to 15 minus over 2 minus x over 15 minus 2. And we realize there's an h value inside. We cannot have anything other than x. Okay, so now the h value we can see again, this is the height of this equilateral triangle. And the height of this equilateral triangle can be found by use Pythag or can use the trig ratios. Okay, so it's an equilateral triangle and we know that 60 degrees, we can use sine 60 degrees to work out the height of this equilateral triangle. And we work out the relationship between y and x. We substitute y back into the original function we have done for this question. But another question is asking what's the domain of this equation? What's the domain of this equation? So the domain of this equation, again, this x cannot be too long. If the x is too long, it's go outside of this triangle, right? It's go outside of this triangle. So my 2x needs to be smaller than 15. So I would say my x is smaller than 15 over 2. I cannot go too far away. Okay, I cannot go too far away. But at the same time, your x cannot be smaller than 0. So I will say x is in between 0 and 15 over 2. Okay, in between 0 and 15 over 2.